Hello and welcome to another video. In this video we're going to be working on lexicographically minimum string after removing stars. And in this one you're given a string S and it may contain any number of stars, and your task is to remove all the stars. So while there's a star you can only do one thing: delete the leftmost star and the smallest non-star character to its left. If there's multiple you can delete any. Return the smallest string possible. So in this first example you have the star, so we have to remove the smallest character to its left. And there's A's, so we can remove any one of them. So the best thing to do here is to remove, well, I guess here it doesn't really matter no matter what, or I guess it does matter, sorry. So if you remove the last A, you get AAB. And if you remove any of the other A's, you get ABA. And so the idea is, like, if I have a bunch of small characters, like think of what the lexicographically small string would be. I want the smallest string possible. So if I have like some star here, and I have like an A here, an A here, an A here, an A here, like which one do I want to remove? I want to remove the last one because I want the string to be as small as possible. So I'm going to remove the last A. So here, that's what you do. Here, there's nothing. So essentially, like if I have a string, let's zoom in. So yeah, if I have a string like A, B, C, A, D, E, A, star. Same thing here. If I remove the first A, then the string starts with a B, and that's not good. So like we get rid of the star. If I get rid of the middle A, then I have A, B, C, D, E, A. But if I get rid of the last A, then this is like the smallest. So essentially what we can do is we can just say, we're going to have a choice of what character to remove, and we're going to go left to right because we have to remove the left star. Like you can't pick which star. But we need some way to know, like, okay, where are all the minimum character? And then like, where's the rightmost one? And how do I remove it? And basically, how do I code this like reasonably efficiently, right? So first let's ask, like, where's the minimum character? How do we do that? Well, for every character, we can have like a set of locations or like an array of locations. So that's like one way, right? So for example, for A, we could store like this is at index 0, 1, 2, whatever, like we've encountered so far. And then how do I get the rightmost one? So actually, if you think about it, so if we go to this example, let's actually use an array instead. So let's say this is like my characters. So let's say this is like A, B, C, A, D, E, A, star. And then maybe we'll have like A star again. So what we can do is for every character, we can actually just have a stack of its locations left to right. So if we just store the locations as we see them, then the last one we've encountered is going to be the rightmost. So let's walk through what that would look like. So like here we have A, and we've seen at index 0. Then B at index 1. Then C at index 2. And then we've seen A again, which we already have at index 3. Then D at index 4. Then E at index 5. Then A again at index 6. So when we come to the star, we can basically say, okay, let's just go through our array. Like, so we can have an array here, or a dictionary or keys or whatever you want to have. I'm just going to have an array of characters. So like this A will be at index 0, this B will be at index 1, this will be at index 2, 3, 4, and so on. And we're just going to see, like, what's the smallest character we encounter. And so to find smallest character is O of 26, kind of like yesterday's problem, where we can essentially go through all the characters we have and what's the smallest. Then we want to pop the rightmost one. So what's that going to look like? Well, we have to pop. But we also want to ideally, like then what do we do? So there's kind of two things you could do. One, you could do all this. So like we pop the 6, and then we put in an 8. And then we pop again, so we pop the 8, and this is our answer. And now we somehow convert this to all the characters we have, and this is our answer. We could do that. So you could go through all of these values and turn them into like a set or something of all the valid indices. So here you'd have like 0, 1, 2, 3, 4, 5, and these are all the ones you'd want. And you just say, like, if my index is in my set, let me return it. Now the other thing you can do that's simpler is we can just make a copy of this string or a character array. And whenever we pop a character, we can just change the character. So because we popped the 6, we can just turn that into a star. And because we popped the 8, we'll turn that into a star as well. And then we can go through our character array again and just take everything that wasn't a star and return that. So that's what I'm going to do. But either one's fine. You could also, another solution that would be a little bit worse, but would work. I'm going to quickly mention that one. So if we go back actually here. So the alternative is you could also have a heap where the heap, you'll have like your character and your index. And you want to pop the biggest index first. So maybe you could store like a negative index. And that would also work. So like A would be at like 0, B would be at 1, and so on. And then you'd put in another A at 3, -3. And then this would get popped out first. So like this is going to be like your front of the heap. And so whenever you hit a star, you can just pop the front of the heap and then delete that character too. And then whatever's left in your heap is your valid characters. So all of these approaches kind of work. I'll just go with the simplest array because that's O of 26. So that's going to be like constant everything. So let's code that. So first what we're going to do is same kind of thing as before. We need, like for every character, we need to have a stack. So let's do that first. So we'll just say list of, yeah, we could use an array, but I'll use a list. So we'll have a dec integer. And we'll call this like stacks or something. And so basically we have to put in 26 stacks. So, and you can think about it in other languages as just an array. So you have an array of 26 things and everything has an empty stack. Or you could alternatively like not initialize stacks until you get them, like whatever you want, it's fine. But I'll just do it this way, stacks, add. And then we're just gonna make a new one. So essentially we have 26 stacks. Okay. So now we're gonna convert this string to a character array. I guess you could argue that that is O of n space. So maybe we'll avoid that actually. So instead what we'll do is, well actually, in these 26 stacks, so yeah, I think we have O of n space no matter what, because, you know, you could put your entire, like in these stacks, you could have every character. So that's already O of n space regardless. So actually let's do the character array for simplicity. So we'll say character array characters equals to character array. Okay. So then next, we're going to go through all of our characters. So we're going to go through all of our characters, and if it's not a star, we're just going to add it to the stack. So first we're going to get the character, so character equals. So if this is not equal star, then just add it to the right stack. So that'll just be the right index. So how do we get the index? So it's going to be whatever the character at is minus a, because a will be 0, b will be 1, and so on. And we can add the character here. So remember, actually, we don't need the character. We just need indices of where it occurs. So we'll add the I here and continue. Okay, now we have the other case of where it is a star. So if it's a star, we're going to go through all of our stacks, and whatever the smallest character is, then that's the one we'll return. So we're going to go through this guy. And we're going to say if stacks get I is not empty, that means there is a character here. So that's the one we'll pop off. So we'll say integer like character index or something. And this will be stacks get I. We can just do pull last, I think, or remove last or whatever. So this is the like the index of the smallest character, and then we're just going to mark that in our character array. So characters char index. We're just going to turn that into a star, and because our character array is an array, we can change that, and that's in one time. So once we did find the smallest, we don't want to keep doing this, so we'll just break. Okay. So now we have this character array. And it's going to have the original stars and the stars that are all the characters that we kind of got rid of. You can change it to a star, hashtag, whatever you want. Or like I said, you can also have the indices left over and your stacks combine that as well. Any one of those works. So now we'll have the string builder result. And so we're going to loop through the entire string again. And so the stars are the original stars and the characters were removed. So we'll say if s character at I does not equal star, then we want this character. So and then finally just return. Oh, we have the same one. So J. Stacks get, so let's think about this. Yeah, this is J. Okay. Oh yeah, we have to convert it to a string. Got the wrong answer. So we got AABA. So did we not convert or something? Seems like it. So let's just double check. So if character is not a star, then we'll convert it and we'll add the character. And then otherwise, if it is a star, then we will pop it. And characters at char index equals that. Okay. So let's print the characters when we do that. Let's see what happens. Okay, so we have the right thing. Are we just looping through the wrong thing? Oh, right, this needs to be not s char at, this needs to be chars or something, right? Chars at I. Yeah. Okay, let's revise. That works. Okay, there we go. Okay, so thinking about time and space complexity. So what are we doing in like all these steps? So first, this is 26. So this is going to be like, if you want to get technical, this is just constant 26. Then let's see what else. So we convert the strings, that's O of n. Then we're checking for every single character. And then we're checking through the stack, but we're getting the stacks. Like this is worst case 26. So basically I would argue it's like n times 26. Now, because I hard coded a 26, you could say this is going to be like n times unique characters or something like that. And then space. Like if you didn't want to hard code and use some other like map or something, you could do that as well. And so this is already n. The stacks is also worst case n. Like imagine you have no stars at all, you just push every character on. So that's worst case n. So yeah, that's going to be it for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.